Welcome to Spaghettimoon's basics of Spaghettimoon's basics of NURBS tutorial. What I want to show you in this tutorial is the basics that you have to work with when you're using a NURBS curve, or more than one NURBS curve if you're making a surface, for example, or joining them together. Practical application will follow in a separate tutorial. When NURBS are a derivative of Bezier curves. NURBS stand for non-uniform rational B-splines, which is quite a mouthful, so let's just think of them as a very popular type of curve. NURBS are a great modelling tool for organic and artificial objects, and too few people use them due to the fact that they think that NURBS are overly complicated, which I think isn't entirely true. The reason that people can think this is because the workflow of actually modelling is very, very different, and both in look and technique. The differences can appear complicated, but I'm sure you get your head around them after this. I think it's unhealthy to get bogged down into just one type of modelling, so I think it's a very good idea to get into curve modelling as well. So in this tutorial, as I said, it's just going to be the basic elements of NURBS curves and surface curves, which are also a type of NURBS curve. Okay, so I'll bring up a curve and show you what it's made of. So press, get rid of this cube, space, add curve, NURBS curve, and you see we've got our NURBS curve there. So first off, I'm going to talk about the cage, which is this wireframe, is what we see apart from the curve in yellow. NURBS are very similar to Bezier curves, and the cage has CVs, like the Bezier curve, or control points, which affects the curve. And you can see that that's not very good. There we go. You see the way that it affects it in a slightly different way, because it's much more detached from a Bezier, as the CVs are a real part of the curve. This one, it's more kind of clinical and apart from it. As I said, this is referred to as a cage very often. If you didn't catch that. The cage defines the curve of an object using a number of parameters, but first off I'm going to show you a way to make the actual curve a bit more practical, using knots, the actual affecting the knots, by changing it from uniform to endpoint mode. Now, as I said, CVs define the curve, but you see we've got these floating edges and we've got the endpoints here, and if we put it into endpoint mode, well, it's in uniform mode at the moment, we went into the edit context, and hang on, I'll bring that up, there we go, and I clicked endpoint, boom, you can see that each end of the curve adheres to that control point at the end. I wouldn't tend to use the other uniform mode, because it's just a bit impractical if you want to do specific modelling. So I usually use endpoint mode to model, because it's kind of easy to see what you're doing with all that ends floating about. It can just get a bit boggling. So we can fix this by setting the curve to uniform, as back to uniform if you prefer that, but I prefer endpoint, so we'll leave it like that. What uniform does is it kind of gives it an equal amount of curve and equal interpolation. I'm not entirely sure about the mathematics of it. I just know that uniform is a bit inconvenient, and endpoint affects the knot vector and makes the curve like that. So it's all pretty simple so far, even if it sounds a bit obscure the way I'm explaining it. Another aspect is order. This little toggle affects the order's here. The little toggle affects the degree of your curve. This amount, I'll just give you a practical example. The amount can only be as high as the amount of CVs as you have on your curve, and even if you have more than 6 CVs, it will go no higher than 6. So if I reduce the order, see what happens to the curve. It instantly becomes, I just take it down once, and it instantly becomes a lot close to the cage, and if I took it down again, you see it's almost completely obscured by the cage in itself. Just like that. As I said, I couldn't put it any further because I haven't got more than 4 CVs. Now another pretty nifty feature of NURBS are that of different weights that can be set onto specific CVs. I don't really tend to think of this feature as weight as such. That kind of conjures up a mental reference of gravity and travelling downwards. So I prefer to think of it as the amount of pull each CV exerts on the curve around it. The higher the weight, the closer the curve will adhere to that particular CV, the lower the opposite, just like this. So I'll select these two CVs here, and I whacked up the weight to maybe 20, which is in this little value here, and then click set weight. And you'll notice how that instantly it kind of pulls its way over to there to create a much more sloped edge down that side where there's less weight being applied to it. Resolution is the same with a Bezier curve. It affects the complexity and appearance of your curve, and deleting and joining NURBS curves are pretty much the same. You select a CV, press delete, or select the two CVs to delete a segment, and C to toggle closed, and F to join curves. Now I'm gonna go on to surface curves, which are another type of NURBS curve. So I'll get rid of this curve quickly and add a surface curve, which looks exactly the same but with some rather critical differences. A surface curve is very similar to a NURBS curve, except for that you can create a much more tangible result very quickly with them. You can, straight up, when you're going to model with them, you've got two options. I'll just put it in perspective mode so you can see it a bit better. You can press E and actually extrude it out. It's like extruding edges, I suppose, in a way. Let's just change that to that point. There we go. I'll just show you, press E, extrude, and I'll go straight to the Z-axis. There you go. You see it comes out there, which is pretty simple, and then you can just model using these CVs, much like you'd sort of sculpt polygon model, but obviously with some slight difference in the technique you'd use. And you can see why the term cage is used here. It's very apt for it, very apt saying. Your second choice is to create a series of profile curves for a NURBS surface, and you'd loft or skin them together, which is that's just a couple of terms there. Which is a bit like placing, say, a bedsheet over some wooden poles to create a tent. It's like creating a 3D object from a 2D commodity, like a piece of paper, folding that up. I'll show you an example. I'll get rid of that extruded one. You can mix extruded and profile curves. So let's add, whoops, wrong one, surface, and I'll subdivide it, press W to subdivide. It's a lot like polygons in there. Create a Control left click faster. Whoop, Control left click on an endpoint selected to add points, and so we've got a nice curve there. And say we wanted to make a similar object, sort of maybe a tube type thing or anything like that. I just select a lot of them, Shift D, and then move them, and I could do that again, or maybe move that one up and box select that lot. They have to be part of the same object, is why I'm doing them in the same. And if I select a lot of them and press F to skin, you can see what I do. See what happens there. It becomes more of a sort of a planar object that's sculpted, because it's actually infinitely thin. There's no volume to it. And that's pretty much the basics of NURBS and surface curves. I hope this pulled back the somewhat mystical veil from NURBS, and I hope this was informative and helpful.